Thank you, Ping-Xiang, and thank you for inviting me to this meeting. So I have a provocative title, Are the Tropics in the Next Glacial Stage? But I will try to answer yes at the end of my talk. So, does it work? Okay. So, and sorry, I will speak about abrupt changes at the end of the talk. But we have two wonderful talks on link between Greenland and the tropics. And here, and it was on shorter time scale than Milankovitch time scale. And I think it's important to go back to the longer time scale at first, because maybe there is some differences. Although I agree completely with the two preceding talks that there is a phase relationship with zero phase between tropics and the ice in Greenland, I think it may be different at the Milankovitch and the precession time scale. So I want to go back a little bit to Milankovitch, which says first that it was a very important discovery that summer insolation at 60 degrees north was changing the volume of the ice sheets, and it was to get growth of glacier. We need a higher precipitation and a lower summer temperature. So in fact, the Milankovitch theory was based on ice volume variations. And it has been proven by, in the 76 by Aix et al. And after it has been improved by many, many different authors. And the main thing was that from orbital forcing, you go through Milankovitch cycle to global climate. And at the beginning, you have something which is a mixture between a 20 kiloyear cycle and 40 kiloyear cycle. And at the end, you end with a 100 kiloyear cycle. And what was very interesting, in 1990, Barbara Molfino and Andrew McIntyre found, I think, a very challenging thing, which was that in the tropics, this was the equatorial Atlantic, you have a precession cycle. And this is a record of Florisphere profunda that I will speak a lot in this talk. And you see that there is almost no 100 kiloyear cycle. So I was a student at that time, and I was very fascinating, and I was studying coccoliths from the Miocene and trying to link with orbital forcing. So I went into the Quaternary and worked on Florisphere profunda as Andrew and Barbara did, and I did a long count of Florisphere profunda, and I found indeed that there is a very strong and pronounced precession cycle. This was in 97. So therefore, the 100 kiloyear cycle, which is the ice volume signature, is not dominant everywhere. This was a first kind of a key, that difference between high latitude and low latitudes. More recently, you have all the pictures of variation in the tropics in the Holocene. This is the Holocene. This is a paper by Conroy, a very recent paper, which is a kind of, I put it here because it nicely shows the difference that you can see between the early Holocene and the late Holocene. And this is in the tropic, this is Gerald Hogg records, and you have many different records from different places, and Conroy record here. And you see that, in fact, the records in the Holocene are not flat. Instead, in ice cores, this is delta 18 in the north, and this is the temperature in the south, different cores. And you see that the records are almost flat. So there is a kind of a difference, and many persons speak about the climatic optimum here, and a change in this area, and which is not found in ice cores. So I wanted to link the two. And therefore, I went to a very high-resolution core in the Banda Sea, which is well dated with C14 dates and delta 18, and it goes to almost 50 centimeters per 1,000 years in the Holocene. It's located close to the Arafura Shelf, and it's a place where we have which experience a strong monsoon. And here you have the field of the wind, and you see that there is a reversal, evidently, and you can see that here in the quick scat record from 9 years averaged, and you see that the main winds is during this boreal summer in August and July, and this is, I'm not sure that I don't see it very well. There is a green line here, and you see that, and you should see that here you have a big peak of productivity and chlorophyll during the dry monsoon, which is winter in Australia, so during July and September. So this strong change of productivity can be pictured by Florisfa profunda. I use now automatic counts of coccoliths through an automatic microscope and artificial neural network. So the counts can be numerous, and here is on this core the reproducibility of two sets of slides, two different types of microscopes, two different types of neural network, and you see that we can have a very good reproducibility. This is represents the Holocene of that core. And this is the entire record in blue here with Florisfera profunda converted to primary production in the Banda C, and below is a delta weighting record. And you see again that here you have a kind of a precession cycle which doesn't appear too much in the delta weighting, which is related to ice volume essentially in this area. And you see that there is a lot of difference between ice volume and primary production. What is most related is not to delta weighting, but first to precession, which is in white here, and also to the speleothem from China, a compilation from Wang that has just been presented before. And here I just want to speak again on the precession cycle, and you see that they are kind of in phase. Here I didn't invert the delta weighting. So in fact, you have the wet monsoon on the bottom of the graph, and here the intensity of the dry monsoon, which is at the same month. I mean, the dry monsoon in Australia is during July and August, and of course the summer monsoon in China is also at that time. And you see, so therefore, it's kind of opposite in a way, in a dynamic. But if you take in this type, there is no phase lag between the two records. And the question is it normal to have this opposition? And here, Pascal Braconneau from Gif-sur-Yvette did a model of the tropic recently using the IPSL MC4, which is a coupled model on this area, and here is the wind stress, which is important for the monsoon that I speak about, the wind of the monsoon, which provokes the change in primary production. And here you see that this is a difference between 9,000 years and now, and when it's green is a negative difference and a positive difference in orange. And here is a value in the Banda C in change in wind stress. And you see that the data are very well correlated at 9,000, 6,000, and 0. And we have the same type of variability for primary production. So this is this area. And for the, of course, everybody knows that in 9,000 years ago, many models predict a wetter monsoon in China, and a little bit less in 6,000 years, and this is the present. So the difference was also very important. So the fact that we have the dry season, the dry monsoon in Australia in kind of opposite phase with wetness in China is logical. So here I come back to the later part of the record, and you see in red, the speleothem from China, and the record of Bandasi in blue here. And you see that what is very interesting me is the change during the Holocene, which is also seen picture in this graph that I spoke before. You have also many African lakes level which were higher during the Holocene. For example, the mega lake Chad between 9,000 or even maybe before up to 5,000, and it ended abruptly 5,000 years ago. You have also the Sapropel one in the Mediterranean Sea, which is linked with maybe linked with the flood of the Nile, which ended 6,000 years ago. You have the Menocal paper that Larry spoke about, which show that in West Africa, in the Atlantic, you have a shift at 5,000 years ago. So many proxy in the Holocene show a huge difference, or some difference, in the middle Holocene, even here, but this doesn't appear in high latitudes. And when you look on the longer time scale, you have these variations which are not clearly visible, or is not the main driving feature of the higher latitudes, either in ice cores or in delta 18 records. People who knows my work will think that I always repeat the same thing. And maybe this is true, since more than 10 years ago I published this paper where I was showing the strong precession cycle, and the advance of, when you look at the phase wheel here, is for people who are not familiar with phase wheel. You look at phase wheel like a watch, and instead of having 1 hour, when you go around, you have here for precession 23,000 year cycle. So the advance of primary production here was in advance with delta 18. And here, a few years after, with Nick Pisayas and Alan Mix and Thibaut Gary Del Torrent, we reproduce the same thing on many cores taken from the Pacific. And you see that in red here are the primary production records, and in blue here are the delta 18. And there is always an advance for every record. This is the same record in the same course of primary production toward primary production. Okay, I accelerate. And this is China's speleothem, and this is my record from Bandasi, and this is the phase. This is how we calculate the phase. So, in fact, Yang Jin said that it was in July, or me I found August, but it's very close because this is very early August, and maybe he was late July, so it's an error bar. Delta 18 from China is opposite. Of course, when you go from monsoon in China, the wetness, you should put the arrow here. But what you see is that delta 18 is in the same quadrant in advance with delta 18. That means that there is a kind of an advance of monsoon toward delta 18. And of course, many records of monsoon are in this quadrant, and this is strange, especially in the Arabian Sea. So I think there is a type of global monsoon which is linked with ITCZ, which is especially well seen in the ocean, and local oceanic systems which are closer to continent can be more complex and having different things. And now I want to very fast go to why I think the tropics are already in the next ice age, is because if you compare what is going on now, this is the Holocene, and you see that there's a big change in the Banda Sea, which is not observed in the delta 18 here. If you go to the Ionian, you have an early decrease of monsoon in Banda Sea, which precedes also, of course, the beginning of the stage 5D. And so if now we are thinking that we are going in the next ice age, the signature of the monsoon is already on since a few thousand years. So it's why I was thinking that in terms of precision, tropics are in advance to the ice volumes. And now, because I am in an abrupt climate change session, I wanted to show that I can speak also the abruptness of the change that is observed in Banda Sea. Here, this is again the Holocene, and this is the two sets of slides that I did for change in a percentage of Florisfera profunda. And you see that the record is shifting from in a step way between 5,700 years and 5,200 years before present, and which is almost equivalent to the same time of Domenocal. It's exactly the same time scale. So this is in 500 years, there is a kind of a shift of precession. So the response to precession may be gradual or very abrupt, and in this case, the shifts are abrupt. This is my conclusion. Thank you.
Again, a provocative talk, open for discussion, please. So actually, my question, actually you believe that the glacier come from tropical rather than from Apollo?
No, I will not say that. I will think that there is a kind of independence. I will think that Milankovitch theory is valid and the change in the higher latitudes are there, but there is a kind of advance in phase, but maybe it's a different system which is working in the tropic. And also, I really think that the phase in Dange-Röschger cycles are extremely well done and valid. So it's just a problem of precision, which is in advance in the tropics. And I will not say that the tropics are forcing the ice.
But what the abrupt change, what the forcing?
This is more complex. I have no really. When you look at many, there are two types of records in the tropics. The one which show abrupt changes, and the one which are progressive. And I think this is a kind of pattern. Maybe the core is located at a place which is from the jet. Something is going on and make it a non-linear response. And but the phase is valid.
Good. Any question more? Yeah, please.
For your Australia monsoon, you showed it's sort of in phase with or out of phase with the Asian monsoon. Just want to clarify.
It depends of
for the precession cycle.
Yeah, we are speaking about July, and wet and dry. So it's completely out of phase if you are speaking about increase of wind stress. Okay. is in phase
with in phase so the intensity both in.
We are not speaking about the same parameter, is what I try to say.
Yeah.
You have an increase of wind stress when you have a decrease of wetness, in a way.
Yeah, I just wonder, because there are observations showing the Australian monsoon in the Holocene was actually out of phase with the local insolation. Therefore, it's in phase with the Northern Hemisphere.
Yes.
Is this consistent?
Yeah, this is consistent, but there's a paper that you refer to are on the other monsoon. Here, I am in the dry monsoon, and many papers in the Australian monsoon speak about the wet monsoon, which is the equivalent to the winter monsoon in the boreal system. Here I speak about the winter monsoon, which is equivalent at the same time that the summer monsoon in the northern hemisphere.
Okay, maybe I'll talk later.
Wind and rain, are they comparable?
Yeah. What about just the precipitation? Is the local summer precipitation, do they, let's say in the early Holocene, 10,000 years ago, Asian was Africa, they are stronger. What about in Australia?
what you're speaking about is this season, and me, I'm speaking about this season, the time where the monsoon is going from the south to the north, and so this is very dry. So my work doesn't speak about the wetness in Australia. It's on the other season.
Time is the limit. Well, I think there was a hand. No? Okay, brief question.
So your proxy has a very strong seasonal sensitivity. Let's assume you had a proxy that's capturing the entire season equally, the entire year equally. Would you still see an effect like this, or would you rather see an obliquity cycle?
A very interesting question. I will say that in a non-seasonal, a less seasonal proxy, you will see very less variation and maybe a completely different signal, because here I'm dealing with the season, and for example, temperature or salinity in this area don't show exactly the same stuff, and they behave differently.